I'm going to talk about dyscalculia from a teacher's point of view. I'm going to talk about the what, why, who, where, when, how, de bono's approach. I've taught in 3 countries, in the UK, Australia and Samoa. I've taught in private and state systems, in all girls, all boys and mixed schools. So you can imagine my surprise about 7 years ago when I heard about dyscalculia. Never heard of it before. What is it? It's a neurological condition which occurs in the left parietal region of the brain. You hear dyscalculia called maths underachievement, maths dyslexia, number blindness, specific learning disabilities in maths, but you've got to have a name for something, else it doesn't exist. Dyscalculia is a good name because it is a disorder of calculation, of arithmetic, not of mathematics. You see, I think of mathematics as being kind of like a field, and in one corner of this field you've got arithmetic, which is a small and relatively unimportant branch of mathematics. You have, in other areas of the field, like probability theory, set theory, geometry, all of these don't need very much arithmetic. So it's perfectly possible to have dyscalculia and be good in other areas of maths. The problem is, of course, that arithmetic is the first branch of maths that kids meet in primary school. And if they can't do it, then they have a huge increase in maths anxiety and a corresponding decrease in self-esteem. So why does it happen? Well, there's evidence from MRI scans that the brain is hardwired to count, and there is what they've called a number module in the left parietal region of the brain. Birds can count up to 3, apes can count, so I don't think that this is such a big stretch. So how do we learn to count? Well, the brain works by associations, by forming networks from the known to the unknown. I call it the coat hanger theory because you've got to have a coat hanger to hang your coat on in the wardrobe, else it'll fall on the floor. You've got to have something known to hang the unknown onto, else you just don't learn it. So eventually you learn to count up to 10 meaningfully, so that you know that 5 means 5 things, whatever the things are. They might be buttons, fingers, whatever. Then you learn to count in 2s and 5s and 10s. Counting in groups is multiplication, and the opposite, its inverse, is division. So all arithmetic is based on counting, adding on, taking away, multiplication, division, all based on the ability to count. So what happens if you've got a neurological condition like dyscalculia, which means that you haven't got a number module in the left parietal region of the brain? How can you learn to count? Well, you use the amazing capacity of the brain to learn. It's called brain plasticity. And you use compensatory strategies. The right-hand side of the brain is used for visual perception, for processing pictures. So exploiting that ability to process pictures, here are some of the concrete materials that I've used when tutoring kids with dyscalculia. I've used cards representing dominoes. I've used dominoes themselves, pictorial representations of number. I've used paddle pop sticks to help with place value, Cuisinart rods for multiplication and division, of course a counting stick with lots of different counters to count in 2s, 5s, 10s, hundreds, thousands. Kids like that. So who gets it? Well, on international figures, there are as many kids internationally with dyscalculia as with dyslexia. So that means about 1 to 3 kids in every classroom in Australia will have either dyscalculia or dyslexia or both. So where does it occur? Well, internationally. The US, the UK, Canada all legally recognise specific learning disabilities like dyslexia and dyscalculia, but unfortunately we don't. So when should you screen and test for dyscalculia? I think grade 2 is an appropriate time. You have to be careful though, because dyscalculia affects arithmetic. So achievement tests like NAPLAN, you can actually score average and still be dyscalculic. I love maths. There's so many skills involved in maths, and so very many different reasons for underachievement. Dyscalculia is only one of them. For dyscalculics, time is very important because it takes a long time for the right hemisphere to process all these pictorial representations of number. So they hate doing tests against time. There's lots of information out there. Mainly research is done overseas. Just remember, dyscalculics count.